Hello everyone, this is Ravi, and in this part I'm going to talk about some design documents and introduction part where it includes the classes, methods and attributes. So in the introduction, this document provides detailed information on Sonobuoy design software. Actually, it describes how different types of Sonobuoy interact and behave after its deployment. Additionally, several object-oriented design patterns have been implemented and discussed in this design. We have also considered different types of environment where Sonobuoy reacts accordingly. So the word is sonobuoy. Actually, sonobuoy is a cylindrical shaped device which is a combination of sonar and a buoy. Sonar is a technique of propagation of sound and its navigation, especially on or underwater, to detect objects like vessels, ships, signals, etc. Sonobuoy is basically used in military and research purposes. And we have three types of sonobuoys in our design, that is active sonobuoys, passive, and special purpose sonobuoys. And active sonobuoys are those sonobuoys which listens and returns echoes, and in this way it knows that what kind of echo it received, so that it will know that whether that is a vessel or any kind of the geothermal activities or any kind of signals. So in passive sonobuoys, it emits nothing in the water, just listen the water waves, sound waves, for instance sound of propeller, noise, ping signal, and any other signals from any source in the form of sound waves. Sound is then transmitted to receiving station. Special purpose sonobuoys, it relays only oceanographic data and not used for submarine or any object detection. It can act as distress signal among others. Special purpose sonobuoy are three different kinds, and they are bathythermobuoy. It relays information on temperature and pressure in varying depth and also relays the salinity of water. And another type is SHARE, that is search and rescue. It is designed to locate aircraft, sunken ship, crash site, or survivors at sea, etc. And another type is ATAC DLC, that is air transportable communication and downlink communication. That is designed to act as a means of communication between an aircraft and a submarine, or between submarine and a ship. Sonobuoys can work in coordinated fashion among themselves. Active sonobuoy can be deployed alongside of passive sonobuoys so that it can relay the coordinates and other important information to an available receiver station. So this is basically the description of operation of our design, how the system works. So it starts from dropping the sonobuoy. So a sonobuoy can be dropped in the ocean from an aircraft to listen for trace noises from enemy submarines or other preferred acoustic sound waves. The sonobuoy is stabilized in flight by a parachute in order to reduce the effect of wind. Upon impact with the water, the parachute is released and the sonobuoy is allowed to submerge into the ocean. At a predetermined depth set by an operator, pressure causes a gas container tube to puncture. The gas expands and separates the sonobuoy into two parts with a suspension cable holding each part together. The upper unit returns to the surface. This unit contains a magnetic compass and radio frequency transmitter. The lower unit, sonar, sinks to a predetermined depth as set in the program based on the environment condition. When the depth is confirmed, it deploys a larger array of hydrophones. The array of 5 telescopic arms set out radially from a central hub. This provides better angular resolutions and allows the sonobuoy system to better distinguish between two acoustic contacts in the same direction. The odd number of arms provides hydrodynamic stability in a situation whereby the upper buoy is dragged by the wind. Any signals detected by the hydrophone are sent via the suspension cable to the upper unit. The signals are modulated by the transmitter and then relayed to an airborne processor of the aircraft or utility ship. So operation of the sonobuoy. After the deployment, the reprogrammed sonobuoy hydrophone antenna picks up specific sounds. Data is analyzed by digital signature processing unit. However, multiple sonobuoy can send data for triangulation purpose. Active sonobuoy emits sound wave into the water and listen for the returning echo. Passive sonobuoy emits nothing other than the sound signal from the ships and other submarines. Any recorded sound is reported. A special purpose sonobuoy is mainly used for monitoring purpose. It is used to measure geothermal, ocean current, and undersea volcanoes. Each sonobuoy has a potential to control onboard sensors and hydrophones for its own operations. The transmitter on active sonobuoy allows active sonobuoy to transmit acoustic sound wave signals to the receiving aircraft. So environment means its surroundings. So once sonobuoy is deployed, several surroundings attributes affect sonobuoy and it starts behaving accordingly. We have identified several attributes and behavior in terms of sonobuoy and its environment. For example, temperature is one of the attributes. This is the temperature of water, and it's measures in degrees or Fahrenheit. And depth, this is the distance downward from the water surface, measured in feet or meter unit. Current, this is the movement of water from one location to another. It is measured in meters per second or knots. Pressure, this is the force per unit area, which is measured in psi. All these are the attributes. And in the methods or behavior, how it behaves, we have environment method. This is the constructor of environment class, and the destructor, this is the destructor of environment class. Likewise, we have attached sonobuoy. This is one of the method which attaches the environment data and sets signal. This method sets the signal from environment class. Another method we have env initialized. So this is this will initialize the environment. And another is buoy signal. This method displays the signal of buoy. And get temperature. This method gets the temperature. And set current. This method records the current of water and returns get current. This method records the current of the water and returns the integer data type. Get depth. This method records the depth of water and returns the value in integer type. Set temperature. This method sets the values of temperature. Likewise, set current. It will set the value of the current. So these are the methods that we have in our design. So and also we have simulated our environment with a text file, where we have saved several values in a text file, and it will take those, our system take those values to simulate. So deployment. So once the sonobuoy is released from an aircraft, it hits the water surface, and as soon as it hits the water surface, our design comes into effect. Program is designed in such a way that when sonobuoy reaches to a certain depth, it gets deployed, breaking apart into several parts and takes its position. And then it constantly gets and sets its surroundings data to the system, where different types of sonobuoys work accordingly, communicating with each other and with the receiving station. So design patterns used in our software. In this software, we have implemented several design patterns to accommodate its functionality. Below are some of the designs. Observer pattern. This is a behavioral pattern which deals with the interaction between classes and objects. This pattern defines one-to-many relationships. When a state is changed in one subject, then that change is reflected in other dependent subjects. In our design, the environment is the subject and all other sonobuoys are the observers. When a sonobuoy is deployed, it is attached to the environment object and is ready to receive any updates. When the environment notices any activity that is sound, distress, or creature signals, it forwards the signal to all attached sonobuoys. Here is a design pattern diagram, how the subject and observers are placed here. So anything change happens in the subjects, there's update method. It should update the changes on the observers. So now next part will be will take over from my colleague. Thank you.